In this section, we're going to look at a one-shot color camera sensor as well as a mono chip that are both well behaved. I'd like to demonstrate what it looks like to take advantage of a bias that's sufficiently different than what we've looked at so far that I think it deserves its own example. Now, before we go into the script of WBPP, if you haven't visited any of the other sections yet, let me just refresh your memory and indicate that if you're going to take advantage of cosmetic correction, which is generally a good thing to do, you have to set up that template in advance. So this is going to be, the first example anyway, is going to have the CFA, the color filter array, and we'll use the auto detect with a sigma threshold to figure out what are hot pixels and what are not. This is a great kind of robust way of taking advantage of cosmetic correction. So I'm going to drag that out here, and I'll give it a name like Cosmetic Correction CFA. And maybe I should have just made the other one when I had it open, but I'll do it again in a moment and make another one. So we have that set up. That means that we can go into the script. And the data that I'm about to show you is part of the fundamentals course. It is part of the workflow section. This is data that was made available to me by a kind gentleman. It's of NGC 300. So it's excellent one-shot color camera data and a really good example of one of these well-behaved CMOS sensors where we can take advantage of a bias. I'm going to use the Add Files button, and let me just show you the directories here. Here we have lights, flats, biases, and darks. So I'm going to open up all of the lights, and I'm using the Add Files because I think that in the headers, all the information is correct, so they should go to the correct panels. There, the flats are there. So we'll put the biases here. Should go to the biases, and we'll do the darks. Okay. Now, one of the things you'll notice about the flats, let me spell this out here. Oop, I want to make it wider. Is you'll see, number one, in his name, it says Dawn, and that should be a big clue that these are Twilight Flats. And Twilight Flats are taken under the condition of constantly changing light source and its brightness. So that means that the exposure time to match a half of saturation type value to get a good light illumination of your flat on your chip means you need to constantly change the exposure time, which is exactly what we see here. Now, there's something about the integration of these flats that happens that I don't know that people pay attention to this, but when you do this manually, you need to specify, hey, these are flats, take care of any differences in brightness, especially in this case, where the program will normalize for differences of brightness so that the difference in brightness isn't going to be a problem when it comes to reject any of the outlying values. All I'm saying is that's automatically taken care of. WBPP has that logic. I'm going to pause myself here and just say that I wanted to say something kind of profound, and I didn't end up doing it in the video, so I'm going to do it now. Notice again that these are all different exposure times for these flats because it's a Twilight flat. If you were going to do this with flat darks, look how many flat darks you'd need to take. You'd need to take 10 or whatever to calibrate this information. But instead, we're going to take advantage of the power of using a bias frame to calibrate them all. Again, the way in which WBPP works is that it's going to calibrate each of these flat images first, then by subtracting the bias, then it will use image integration to combine them, and as I mentioned, it'll use it in a way that normalizes them. So the fact that they're different exposure times isn't a problem. But the benefit I neglected to say, and that's the coolest part, is that this would be much more difficult to do, say Twilight Flats, if you had to generate a flat dark for each of these exposure times. But we can check some other things here. If we look at the lights, you can see that the lights, well, they're 120 seconds, so the darks should be 120 seconds to calibrate lights. And then there isn't really a filter here. This is a one-shot color camera sensor. yet the software that acquired the data wrote a word here in the filter spot. Now, it doesn't matter what it writes, as long as it writes the same thing wherever it matters, which would be in the flats. And it did. Character for character, these are identical. This is exactly the job that the control panel is going to do for us, but we can do it visually by inspection here as well. So everything looks right to me. In the lights, for the integration to create these masters, there's nothing to change. I'm just going to use the automatic settings here for image integration to create the master bias, to create the master dark. Just keep it on automatic in this case. In fundamentals, I explain in much more detail when you might want to adjust these settings. But the settings themselves are for the auto. They are particular, they're based on the number of frames, basically. They're set up in particular brackets, I guess, of numbers of frames. And for flats, again, I just explained that those are going to be taken care of properly. So here, for the light frames, let's pretend, I'm not going to actually process this data, I'm not going to tell it to do anything, but this is just the setup. So we would set this up with a Cosmetic Correction instance, and I am concentrating in this tutorial on just doing the pre-processing. Later, I'll have a section that goes these other two steps and talks about the weighting, image registration, and image integration of the lights. So that's it. I think that pretty much sets it up. We should be able to go to the control panel now and see what is going on. So what we want to be sure when we come to the control panel is everything is matching in the way that we expect it to. So, for example, even before we get to matching, do you notice how there's a little black and white image here for CFA images? We should tell WBPP that these are color data. So let's click on the lights here, and you can expand these if you can't read what it says underneath. But click on the lights, and now over here some of the options will show up, one of which is we can tell it it's a CFA image. Now you'll see a little colorful thing here. We'll do the same thing for the flats. Turn on the flats, and I've been using this scaling of the individual channels, so I also check this automatically, the CFA scaling factors. I think that's fine. So now we have all the color stuff set up. Now specific to the flats, you'll notice there's a status which is a little warning. And whenever we see a warning thing here, we'll have a message. The message is that the flat frame's exposure differs from the master dark's exposure by more than 5 seconds. That is very true, because this is a 20-second exposure and this is a 2-minute exposure. But this is all assuming that we want to use a master dark, which we don't. We want to use the bias. The reason why it's telling us this is because we're telling it, use the dark frame. And that's what's spelled out right here. This checkbox means use a dark, and then this setting here for what is auto, this is the setting that says match either automatically or pick one. Of course, in this case, there's no difference because the auto, there's only one dark, and that's the same thing right here. But we don't want it to use a dark at all. So I'm going to uncheck dark, and then you'll see that the little dark column, I should have shown that. It was checked here. That means it was trying to use it. So we uncheck, and now that becomes no dark, and that leaves just the bias in play. And that's exactly what we want. Now the dark frame is not illuminated, not lit up, but the bias is. It means that these flats will be calibrated with the bias. Now let's see that in another way. Show calibration diagram, and there we are. We have our flat, and there's the master bias being subtracted from the flat to give us our calibrated flat. That's exactly what we want. So having done that, let's look at the light frame. Now for the light frame, we see kind of everything in play here, which kind of makes sense. We are matching, obviously, the filter for the flat field image, and then we are matching on the dark, the exposure time for the darks, and then the bias is still lit up. Are we using the bias for the light frame? And the answer is kind of. It's not really in play, but I'll show you. Because we are loading biases there, it's going to take advantage of it, but at the end of the day, mathematically, if we had turned it off and just subtracted directly, the dark frame, then that's all it's going to do. Let's look at the calibration diagram, and you can kind of see what I mean here. What happens is the master dark just kind of gets divided up because you subtract the master bias from it. So all that happens is the master bias is subtracted from the light first, so that goes away. And then you take the master dark and you subtract off the master bias, whatever little extra piece is left over, that gets subtracted, which is the same thing basically as this master dark altogether, or these two pieces. So that's how you get to this point of being able to apply the flat, and then of course you have your calibrated light frame. The last thing that might concern me, because this is just me, I don't remember, always keep in mind, make sure that you know the Bayer matrix pattern. Because I'm using someone else's data, I would want to check in advance. You should know whether that information is recorded in the header or not. If it's not, you should spell it out, exactly what the pattern is, so that it'll correctly de-Bayer your images when the time is right. So that, I believe, is the setup that we needed, and this demonstrates the use, most importantly here, the use of a bias to calibrate the flat field images. Now we're going to look at a monochrome sensor that's well behaved, one in which we can take advantage of the biases in order to calibrate the flats. And what's nice about this example, unlike the one-shot color sensor example, is that now we're going to have more groups because we have filter groups that'll be in play for each of the filters that were used. Now, before I go into WBPP, as I've shown previously, I am going to create the template for cosmetic correction. This time, however, I don't check the CFA box. I'm going to use my favorite method here of auto detect with the sigma threshold being set to 3, the default value. Make a template and give it a nice name. You don't have to give it a name, I guess, but it's nice. There it is. So this is ready for us, and now we can go into WBPP. Now I have images, wide field images, lots of them, of a piece of the torus molecular cloud. So many, in fact, that a lot of them are very poor because of clouds. So I haven't gone through them. I'm choosing to calibrate them all first, and then I can go through them and look at the quality. I'm going to use the Add Files button here because I am pretty certain that everything should be written properly to the headers, and it'll just put the files in the correct spot. These are the data, and there's a lot of them. Let's open that, and it should load all of that into the into the lights panel. And I do see lots of files in here, red, green, and blue. That looks good. Now I have the other stuff in other directories here. So I have the biases here. These are recent biases. That should have gone here. Perfect. Then we have darks. Now, yeah, I have a whole bunch of different darks at this temperature. I'm going to load them all, but it'll only take advantage of, that'll be nice to show, it'll only take advantage of the correct time. So we should see 600-second darks in here, 60-second darks. Is there a 90? Yeah, 90-second darks. So we have 3 different darks, although I'm only going to be using the 600 seconds. And then the flats. I need to find flats as well. So flats are in here, here. Load them. And additionally, these are going to have many more flats that are necessary. We have blue, and then I have some green and red, but I also have some scientific filters in here as well. We won't be using them, but they're going to show up in the control panel, which again makes it a nice thing to look at and see how the matching is going. As far as the image integration for each of the construction of these masters is concerned, I just let WBPP do its thing. It'll pick the correct combination, well, rejection method based on the number of files. And biases are fine, and the darks are fine. Flats should be fine, no problem. Lights, of course, we're going to turn on our cosmetic correction. I am choosing again just to do calibrate only, so I'm not turning on any of this stuff. That means that we can go right on over to the control panel and see how things are going. Now I'm going to stretch this a little bit so we can see a little more. There we go. Okay, now we have all kinds of little warnings there. That's all right. We already know why. Let's start with, well, let's just go ahead and start with, I guess, the one of the ones that we actually intend to use here is this blue filter. So this is a flat. Remember, this is the flat panel here. This is these are the groups rather for lights. These are the groups for flats. These are the groups for the darks, and of course the bias group. So what we want to tell WBPP is that these are monochrome images. That is the default, and we don't want it to use a dark. See, the dark is checked here. That means it's trying to match a dark frame to it, and that isn't what we want. We want it to use the bias. This is that example where we take advantage of the bias frame. So we uncheck dark here, and then we're happy. That's the whole idea. We get happy when we do that. Now we do, because I have a whole bunch of different groups here, we do need to do that on each of them. Now that actually takes care of what I actually need, but just for the, see, these other groups don't matter because I'm not using them. But we'll go ahead and we'll make it look pretty. We'll make it look right with check marks all the way down the thing. Okay, so now you can see that these are going to be calibrated with the master bias. Now for the light frames, we want, of course, the blue to match the blue, the green to match the green, and the red to match the red. So far, so good there. And we also want the blue to calibrate with the 600 second exposure and not the 90 or the 60. And that also looks good. So we are very close to having this all set up. We can do the additional thing, which is to check if we click on one of the flats, we can check our little calibration diagram, and this just verifies indeed it's going to use the bias to calibrate our master flat there, which is perfect. And excuse me, yeah, our flat to make a master flat, which is perfect. And then we want the light frames. We can see that. Now, because we have a bias lit up here, it is going to show us the more complicated version of this, but we're not actually optimizing. So you can effectively think of, if you recall my diagram from the calibration section, there's a K value here, but the K is going to be 1. So we're not changing we're not optimizing for the dark current to match anything. It just goes right through. And then, of course, we apply the flat, and then we have a calibrated light. So let's hit the Diagnostics button and see what it says here. It says, it's just giving me warnings about flat frames, and there's a whole bunch of them because I have a whole bunch of different groups of flats, but it's the same, basically the same statement. Ignore the fact that I don't have an output directory. I would, of course, if I were ready to press the button. So for the flat frames, it just basically says no master dark will be used to calibrate the frames. Instead, it's going to be the bias. I'm thinking about this. I think I would prefer that it says it's using the bias here, but this is a true statement. No master dark will be used. We can just see when we click here, and I just want to remind you, we can actually see what it is using, not just the contrary statement, what is not being used, but this is actually what is being used. So just know that that's true. And that's true for every one of these flats. So that's all that's saying, is it's going to use the bias and not a master dark, which is absolutely correct. So what I'd like to do next is I'm going to clear this and just show you one more example, but I'd like to show you the example where, see, I've been loading groups. What happens if you just give it masters just to begin with? What does that look like? Of course, it looks very easy, but we should just do it as an example. So I have, let's see, yeah. So I have some data here. This is of a different data set, but one of the things that I'll find, let's pretend that I already had masters generated from some previous set of information. So I would load all of my light frames here, like this. Those should show up, and it's taking it a moment. There are quite a few. So these are all the light frames. We have red, green, and blue data here. And then instead of adding groups for the calibration data, I'm just going to go into my masters. So I guess I don't have a masters here. Okay. Well, I'm going to go find a masters then. I should have a masters. Let's try. I got to go find one. Not this one. Well, I should have one here. There's some masters. Excellent. All right. So I would load masters taken from a different night. That is the idea here. In fact, I won't even... Well, I can highlight them all. I guess it doesn't matter. Here, I'm going to turn off the scientific filters. There's no sense in even using those. There. So that's... Oh, right, turn it off. Okay, so now I have the masters I think that I want. I have a red, a green, a blue, and then I have some darks, and then I have my bias. So those should go into the correct spots. Here's the master bias. Here are the dark frames. Here are the flats, the only ones that we need. And of course we still have the lights. So this time when we look in the control panel, we're just going to see some lovely masters in play instead of a group of things. But that doesn't change in any way any of this logic. So here, there's nothing to calibrate as far as the flats are concerned. Master flats are already calibrated creatures. So just remember that whenever you load a master flat. They've already been calibrated at this point. So now they can just be used. All we need to do is match them to light frames. So this light frame matches that flat. This green matches the green. The blue matches the blue. All of that is perfect. And of course, the red here, it's matching the red, but it's also matching a 600-second dark frame. And the same is true for each of these. So they match there. So let's look at what it says here. I mentioned a moment ago that master flats are already calibrated. So if you look at the calibration diagram, nothing's happening because the flat is the calibrated flat. So there's nothing to flow there. Now, if you look at one of these, it is possible that if you wanted to try to optimize, if we didn't want to use a matching dark, or even if we wanted to optimize on the same time, we would need the bias to do that. But that isn't my intent here. So the question becomes, why is the bias necessary? It's necessary. It's not necessary. Why is the bias here? I mean, what is it taking advantage of? We don't need the bias here is the point. I can remove it if I'm not optimizing. If I'm not using it for the optimization of a dark frame, I don't need the bias in this case because my master flat is already calibrated and I'm matching to an exact match on the dark. I don't need the bias. So if I wanted to, I can even clear this. I don't need it. And everything else is still going to work out just fine. So this is the complete example when I have the masters in hand and I'm not doing any optimization. This is all I need. I'm matching my dark here and I'm also matching the filters here. The master flats. So everything is done. Everything's taken care of. So that's the slight variation when you have masters as opposed to when you have groups, and then you need to make sure that the groups themselves, in the case of flats, are being calibrated properly. But here they're already calibrated, so all done. That was the very quick demonstration for both I did in the previous section, the one-shot color sensor that's well behaved, and here again is a mono chip that is well behaved. In upcoming sections, I'm going to show you a couple of other more complicated examples to show you that WBPP has some real flexibility in being able to do some things like additional grouping of perhaps you have multiple nights and some other interesting creative ways of interacting with your images.